Now, I have slated Phoenix Gold in previous videos as they are not the company that they once used to be. However, they have just released a new 5K, and I believe this to be one of the biggest amplifiers that has ever been released under the Phoenix Gold name. So let's have a look and see what's inside this thing and see whether this lives up to their past reputation or whether this is just another quick cash grab with a very poor quality circuit. So let's have a look. Now, initially I can tell you right off the bat that this is a clone of the Sound Digital circuit. However, it's not the exact same ones that you'll see coming out of China from all of these other brands like Sundown SFB, B2 Riot, Ground Zero GZCA, Defbon's Apocalypse, Baseface, etc, etc. This isn't just the same board that they're buying from the factory. Phoenix Gold have actually moved things around a little bit and at least kind of tweaked the layout, and that suggests that there has been a bit of R&D gone into this one, and it's not just a cookie cutter off the shelf from China clone of the Sound Digital, but it is basically the same circuit. So just quickly going over it, we actually have two sets of terminals, which is unusual in a 5K in this kind of smaller Brazilian style size. We have our two power supply transformers, we have our power supply MOSFETs along this side, we have 4 rectifiers here and here, and then we have our output MOSFETs. Now this is based on the 20957S drive architecture. We do have, if I can find it, there should be an MCU that's running the power supply. Where actually is it? Oh, here it is, sorry. Here's the MCU that's running the power supply protection, yeah, that generates the pulses for the power supply switch mode to work on, and that also sets all the protection modes and the health check at startup. So that's exactly the same as the Brazilian Sound Digital clones and the original circuit. Let's power it up, and we've got 12.4 volts going in. So if I hit the remote just now, you can see it goes through its health check mode. We get the protection light come on at first, and it goes to blue, and that is telling us that, well, the clip light was on at first there. Is that normal? Let's power it off again. So we have health check protection on at first, and then the clip light comes on to start with and then goes off once class D switching initializes. We have 2.4 amps worth of idle current draw. We have an output switching frequency of 140 kilohertz. This is supposedly a full range amplifier if you want to use it that way. This isn't really high enough to be used full range though. And the power supply switching frequency is 26 kilohertz. Now let's just have a look at the design choices that have been made. Over here by the output MOSFETs, we have 1 ohm gate resistors, and the diode there is a 15 or 18 volt Zener that goes from gate to source. There is no 4148 diode across the gate resistor. Now this 1 ohm gate resistor is going to cause some very hard switching on the output MOSFETs there, and it's not ideal. The 1 ohm gate resistor is to allow these FETs to turn off quickly by the drive circuit, but it's not really offering much kind of dampening of the drive signal because it's such a low resistor. I would prefer to see a higher value resistor and then a 4148 diode in parallel to turn it off quickly. So if I set the scope here to 5 volts per division and AC coupling, we can have a look at the low side drive wave here of the here, and you'll probably be able to see this is very hard switching. If we power this up, okay, there we go. That is what the gate drive looks like on the low side. As you can see, tons of ringing and very sharp and harsh. So that is as a result of the 1 ohm gate resistor. Yeah, not really ideal. Very hard switching. I suspect there's some cross conduction or some kind of heating of the output FETs as a result of that. The drive from the 20957s are buffered just like in the rest of the clones by here U6 and U7, and down here U2 and U1. Ideally, you want the drive buffers as close to the MOSFETs that they're driving as possible, but over here they're bloody miles away, and you've got long traces, which is going to be increasing the gate capacitance along the trace and causing a bit extra ringing and stuff like that. In terms of build quality, it's all pretty seated down quite nicely, not too bad, can't really complain there in terms of build quality. It's pretty sturdy. These don't really suffer from vibration damage, so that's pretty good to see. Now, in terms of the RCAs, we have Tiffany style, and we have both of these being input. Let's get on to how this behaves with an audio signal playing. So let's go ahead and set this to 27 Hertz to start with. Nice low signal there. Power this up, and we're going to probe the speaker terminal over here. and let's have a look at what we get. So as you can see already, we have quite a bit of Class D switching remnants. This is going to be up at the sort of 140 kilohertz range. So let's zoom out on the time division here. Yeah, pretty noisy there. And if we DC couple the scope, you can see that we do actually have half rail present on the speaker terminals at all times while it's powered up. If we power the amplifier off, that remains there. So you'll always have high voltage DC on the speaker terminals. Bear that in mind if you're using one of these. So don't touch the speaker terminals or let the speaker terminals short to ground when the amplifier is off or shortly after being powered off, because there is still DC there. That's just how these work, because there's a single positive rail on these rail caps. There's no dual rails. So let's just power this up again. Let's have a look at our frequency response, see what we're doing. We're supposed to have a low pass filter with a 50 hertz as the minimum setting, and the maximum setting is 15 kilohertz. So not quite full range, but you know, up there, kind of like PA style full range, I guess. And the high pass filter is 15 hertz to 1 kilohertz. So let's just have a look and see whether that's sort of roughly about right. Gonna AC couple the scope again, just so we can kind of hone in on that sine wave there and increase the amplitude a touch. There we go. There's clip point right there. I'm going to reject high frequency so we can see it a little easier. Okay, so I've got 28 hertz going in right now. I'm just going to calibrate the scope here for just on these lines here with 28 hertz. So if I increase from 28, we're going to go up to a little higher. Here we go. So we're currently at 36. Okay, so we're starting to taper off. We kind of start tapering off at about 40 hertz here. So with the low pass filter set to 50, we start getting this sine wave amplitude tapering off at about sort of 37, 38, 40 hertz. And then by the time we get to 50, we are down at about here. And then continue on all the way up to sort of 90, we're down here. So yeah, pretty good, I would say. And we are flat on the lows if we kind of start here at 37-ish. And then we go down from here, we're still flat, so the high pass filter hasn't kicked in yet. High pass filter kicks in at about, starts rolling off at about, wow, actually it's still full output pretty much by like 17 hertz. I'm going to need to just change my scope, my frequency settings here to get that to go even lower. Okay, let's continue down. So yeah, we're still pretty much at full output down here, 16 hertz, and we start noticeably tapering off here at about 12 hertz. Okay, so yeah, that subsonic filter or high pass filter at its minimum setting is definitely letting some decent low frequencies through. And the fact that the low pass filter starts cutting off the frequencies around 38 hertz means that in stock form, if you're using this as a subwoofer amplifier, you would want all of these dials turned to their minimum position like they are here, and this is going to sound fantastic on 99% of your subwoofer builds. If you wanted to get some more kick bass, if you've got an efficient driver that has decent, you know, motor force and stuff, you could increase the low pass filter a little bit, but I wouldn't recommend that on, you know, most modern car subs. They just don't like playing anything really above 40 hertz. It's just going to cause clipping and yeah, just not very nice. That's pretty good. Okay, now in terms of power, I don't have a bench power test thing here big enough to bench this to full power, but my good friend Simove02 does have a massive lithium battery bank that he can bench test this to full power, so perhaps he'll do a video in the future. Go subscribe to his channel. But I just thought I'd give you an overview of this. My overall thoughts about this are, okay, this is quite a nice amplifier. It's one of the better clones of the Sound Digital circuit. Time will tell with its reliability, but it seems to be assembled pretty well. The board is nice thickness, you're not going to suffer from vibration damage really here. The capacitors are not any kind of real branded ones, but you know, they're not super crap either. They're not the cheapest bottom barrel stuff. You got dual inputs here as well. It is very compact for a 5K. I would like to see some better circuit optimizations though, especially in the output drive circuit. But in terms of how the amplifier is going to sound out of the box with the preamp circuit, that's all good. Dual inputs, nice build quality. But the biggest thing with this is cheap for a kind of Phoenix Gold 5K. They tend to price those things up. I think in the UK you're looking at spending around about £450 or maybe £420, £450 on this brand new, which sounds cheap for a 5K if you're coming from like the Korean brands or other, you know, sort of older prestige brands. However, this exact circuit you can buy from the likes of Bassface or Soundcubed or just all these other brands now that are coming out with this basically exact same circuit design for like half the price of this. The Bassface Team 5K, which is the exact same circuit, just kind of a more cookie cutter off the shelf from the Chinese factory. It's not been tweaked in any way, but it's basically the exact same circuit. You can buy for as little as like £220. So it's like half the price of this for essentially what is exactly the same circuit. So yeah, it is not bad, but it is a hard sell when you compare it to the others that are on the market, which are based on the exact same circuit. So I hope that's interesting. If you've got any questions about this amplifier in specific, feel free to give me a shout and I will answer you in the comments. But go and check out Sinewave02. He's probably going to be doing a bench test of this to see whether it actually makes its rated power. So I highly recommend you go and subscribe to his channel. But peace out, catch you in the next one.